Another banger. Welcome to another episode. Here we'll start with differentiation. Now, you know that normally differentiation is the process of finding the derivative of a function. What's the meaning of derivative of a function? Derivative of a function simply means what? The slope or the gradient of a function. Now, it is the idea of differentiation is gotten from the slope of a graph. Now, let's check. Now you know that normally if you have a line here from your practicals, physics or math practical, that you have to find the slope of a graph, right? So I will draw a big triangle, right? And this will be x1 y1 abi, and this guy will what? X2 y2. So the slope of a graph, normally what's the slope? The slope is change in y over what? Change in x. So now what is the derivative of a function? Let us say this is a straight line function like y equals to f of x. So definitely the derivative of this is given by, from first principle, we say from first principle the derivative of y with respect to x is defined as still we have dy dx. So that means we are saying that derivative, which is dy dx, is also the slope of that graph, but there is a difference. It is also the change in y over what? Change in x, but you take the limit as delta x tends to what? Zero. That's the difference. So the formula is this: limit as delta x tends to zero of, instead of writing change in y, I can write it as, since it's a function, I can write it as the final value of the function minus, just like y2 minus one. Y2 is this, y1 is f of x gangan, then all over what? The change in x, which is here. So this is the definition. So this is the definition of dy dx, the derivative of a function from first principle. So sometimes we take delta x to be what? To be h. So we can replace it on with what? H and h. That's the definition. Quickly, let's go straight into the example. So here we have to differentiate this guy from first principle. Now from first principle, it means we are using the definition or the formula given in the previous video, sorry. No, so now what is the formula given here? So we know that, we recall that dy dx, normally what's the formula? We have the limit as delta x tends to zero of what? F of x plus delta x minus f of x, abi, that's the formula, all over what? Delta x, right? Má tò le, you understand? So what is f of x? F of x is this, right? This is f of x. Now what is f of x? F of x plus delta x, it means whenever I see x, I am putting what? X plus delta x. That's the meaning. So yeah, let's go. So we have what? Limit as delta x tends to zero into bracket. What is f of x plus delta x? That means this will be 3 into x plus delta x square, meaning I am substituting x plus delta x for what? X inside this, then minus what? Minus 5. Simple. Then minus, in bracket, what is f of x itself? That will be 3x squared minus what? 5, close bracket. Then all over what? Delta x. Are we following? Now if you have a question, just let me know in the comment section. Now we have the limit as delta x tends to zero. Oh yeah, let's expand it very quickly. We have what? 3, right, into, oh yeah, expanding this one, we have what? X squared plus 2x delta x, okay, plus delta x squared plus delta x squared. This is what we have for only this expansion. Then minus what? Minus 5. Then use this minus to expand, that will be minus 3x squared plus what? Plus 5. Then all over, don't forget this delta x in brackets. So we move on. So expanding this now, what do we have? We have the limit as delta x tends to zero. Yeah, expanding this, you have a 3x squared, eh, 3x squared plus 6x delta x, abi, plus 3 delta x squared minus 5, because we know that even this minus 5 would have cancelled this one, so we just only have what? Minus 3x squared, then all over what? delta x. Can you see? It's getting simpler, right? So that means also 3x squared minus 3x squared is what? 0. So we have only this. So we have only this 1 over this. That means you are dividing each by delta x. So in the next step, that's what you do. Delta x tends to 0. Yeah, this is what? 6x delta x all over delta x plus what? 3 delta x squared all over what? Delta x. This delta x cancels what? Delta x. And delta x cancels one of these. This square is meant for delta x, not only x or not only delta. It's meant for delta x, right? Just like sine square x or sine x all squared. All right. So what do we have left? We have 6x plus 3 delta x. So we now say that as delta x tends to 0, now substituting, we have what? 6x plus what? 3. Oh yeah. What's delta x? That's 0. Tending to 0. After you evaluate the limit. So the answer will be what? 6x. So definitely let us confirm from the normal formula for differentiation. If I want to differentiate this normally, which we are going in the next video, 3x square, yeah, differentiate, that will be 2 times 3 is 6, 6x, and we are correct. So this is how to solve from first principle. I hope you enjoyed this video. Please share and follow.